Good morning, everyone. Miss Hafley here for another day of an investigation. Today, the investigation that we will be doing is understanding net force. So let's go ahead and get into it. Okay, so in this investigation, like I said, it is called Understanding Net Force. We're going to look a lot about that. We'll look at calculating net force and look at unbalanced and balanced forces as well. Okay. So let's see what happens to an object when there is more than one action force acting on it. So look at the forces on the car. Okay, where are the forces are on the car? Well, the things that are pushing or pulling on this vehicle. So it would be the three people here. So when there is more than one force acting on an object, we can calculate the net force. And so the net force is the total strength of force on the object in the direction that it is in. So we have this boy here, he's got 100 newtons of force. This girl here, she's got 200 newtons of force. And then this man here has 125 newtons of force. So everyone is pushing in the same direction. So the forces, we can then add those together to calculate what the net force would be. So we would add 100 to 200 to 125 newtons. Okay, so we'd add all of those up for a total net force of 425. Excuse me. What direction would it be in? Well, when we look here, all of these arrows tell us the direction. So all of this car, it would be moving in the direction to the right. So what way will the car move? To the right. Okay. So these dogs are pulling on a toy in opposite directions. So when the forces act in the same direction, we add them to find the net force. But what about, like in this example, where they're in opposite directions? Well, we actually would subtract the smaller force from the larger force. So we would subtract the 65 from 70. Okay, so what would the net force on the toy then be? So 70 newtons minus 65 newtons gets us 5 newtons. But in this case, what would the direction be? Well, the direction would be in the way of whichever dog has the strongest force, right? So that would be to the left and slightly up, because if you notice, it looks like it's kind of going upwards towards the top of my screen versus the bottom of my screen. Okay, which way would the toy move? Again, in the direction of the force that is stronger. So to the left and slightly up. Okay. In this photograph, each person exerts a force on the bridge. What is the net force that the people exert down on the bridge? So again, we would add each of our forces. So 650 newtons plus 750 newtons plus 800 newtons. And we would get a total of 2,200 newtons. But why isn't the bridge falling down? If there's plenty of force acting down on the bridge, why doesn't it fall down? Well, the answer to that is because since at the bridge it has supports on both ends, so we can, see here, we can see that it has supports there. So in this calculation, we're only looking at one part of the system. It's the people and the bridge. We did not consider the ground or the bridge supports in that equation. So since the bridge does not move downward, the supports must exert a force upward. But the bridge doesn't move upward either. So if it was going to be moving upward, that would make it an unbalanced force. So if they exert that much force downwards and the bridge doesn't move upward either, okay, the same amount of force is being applied upward as well. So the same amount of force as applied downward, so 2,200 newtons. So those people are exerting a force downward of 2,200 newtons, and the bridge itself is exerting a force upward of 2,200 newtons. And this would be an example of a balanced force, since there is no motion whatsoever. So if there is motion between two objects, so like with the dogs or with the car, that would be considered an unbalanced force. But since the bridge does not move upward or downward or left or right, it is considered a balanced force. So the force of the supports upward equals the force of the people downward. So what is the net force on the bridge when we include the supports in this system? Well, it would be a total of 0. So there would be 2,200 newtons downwards minus 2,200 newtons upwards. So we get a balanced force of 0 newtons. So whenever the forces are balanced, the net force is always 0. Okay, so are these forces balanced? So she is pushing to the right with 88 newtons, and he is pushing to the left with 86 newtons. Okay, so is this a balanced force? Well, no, the net force is not 0. So we would calculate this and say that this is an unbalanced force. And it is unbalanced in the sense that there is 2 newtons of force. And which direction is it going to move? Well, it's going to go in the direction to the right because she has more force. Okay, so whenever forces are unbalanced, there is a non-zero net force. And when there is a non-zero net force, there will be a change in motion. The object will accelerate. Okay, what does that mean to accelerate? Well, that means a change in velocity. Okay, so it's either speeding up or it's slowing down. So we're going to use this simulation here to understand balanced and unbalanced forces. In the net force simulation, we're going to drag different people to the rope. And when we add more people to one side of the rope, what happens to the force on that side of the rope? All right, so let's go ahead and we'll do 2 people on this side and 1 person on this side. I'm going to show the sum of the forces, and we'll go ahead and show all of those things here. Okay, so what happens? Okay, so the blue side won. So when you add more people to one side of the rope, what happens to that side of the rope? It increases. Okay, so the force on that side increases. So when we see here, there's 250 newtons of force and only 150 newtons of force on this side. All right. So now we'll go ahead and do a couple more examples here. Okay, so in this one, let's try. Let's do the same amount. Okay, so what happens when we do the same people? So there is no motion at all here. So the sum of our forces, so the net force is 0, right? Because they have a force of 250 newtons and they have a force of 250 newtons. So really, in this case, this is technically considered a balanced force. There is no acceleration. There is no change in the speed or the velocity here. And so, no, this is not a balanced force. All right, so let's see if we add everybody on this side. So again, you see now that the right side, the red side, has 350 newtons of force. The left side has 250 newtons of force. And so because the net force was 100 newtons to the right, there was this force to the right that it moved to that side. So there was a change in the speed. So this is an unbalanced force. Okay, so if the forces are balanced so that the net force is 0, can the object move at all? Well, we just kind of saw that. So when we put 2, they are the equal. Sum of the values are both 150 newtons. The object does not move. However, as soon as I add another person to another side, it does change. But this person over here still had more force. Right? So if we were to do it again, and have the same amount of force, it does not move. And so we would see that there is a sum of 0, a net force of 0. Okay, it will not accelerate. It must already be in motion to begin with. Okay. So consider this example. So suppose the star explodes. Pieces of it were flung into space. But after the explosion, no forces act on the star pieces. There is no force to speed them up or slow them down. They continue moving with a constant velocity. So thinking about that, when we looked at the phenomenon of the wrench being thrown, right? How would we describe the net force? So the net force again on this would be 0 because nothing is speeding it up or slowing it down. However, if the wrench in space does run into something, then the net force would change, maybe either making it speed up or slow down. Okay, so net force, even though it is balanced, can an object move at all? In some cases, yes. And so the wrench is an example of that. So as long as it's not changing in its velocity, then it will continue to have a net force of 0. So it can be in motion, like the wrench being thrown in space, but nothing is speeding it up or slowing it down. So that means that there is a net force of 0, and this would be considered a balanced force. Okay, so in the simulation, as you added more force to one side of the cart, how did that affect the speed? What was the pattern? As more force was applied to one side of the cart would move faster in that direction. So when there was 350 newtons of force on the right side and only 200 newtons of force on the left side, it would move to the right. Okay, so if 600 newtons of force pushes a cart in the right and 200 newtons of force pushes the cart to the left, what is the net force of the cart and what direction is it in? So we would take 60 minus 20, and that would give us 40 newtons of force. And since there was more force to the right, it would move in the direction of the right. Okay, if there is a non-zero net force of an object on an object, what will happen to the object's motion? It will just not change. The object will accelerate, meaning it will speed up or slow down. I'm sorry, non-zero. So it will change if there is a non-zero net force. So it will speed up or slow down or change direction. If it is a 0 net force, it will not change speed, meaning it won't slow down or speed up or change direction. Okay. Alrighty, so hopefully this helps you guys out with your assignment, and I can't wait to see you again next time. Have a great day.